Hello friends, this is second video of unit 4th, topic image segmentation, Haugh Transform. This video is recorded by Shri Ramurthy Smarak College of Engineering, Technology and Research, Bareilly, by Sachin Kumar Saxena, Assistant Professor, Computer Science and Engineering Department. The subject is image processing and the code is RCS0. Let's see how image processing is using for edge detection using Haugh Transform. First and foremost, we will have the brief study about Haugh Transform. Then we will see how this edge detection is useful for different images, and the aspects are different objects also. So in the Haugh transform is very useful for every image. We can utilize, transform or screw the different parts of any image with Haugh transform. As you can see, there is certain input image which is having certain pixel values ranging from 0 to 255. That is input to the transform function. First and foremost, it is converted into the binary format, that is the having value 0 and 1. Previously it was the gray level scale, that is having 0 to 255 scale. Now it is having binary image. It means it has detected the edges from the image. Now the second image depict the edge image performing the different image, and it is also binary image, means having value 0 and 1. In the third image, it is illustrated detected lines, that is from the variance of the partition and variance of the gray level images, means from certain, for example 244 or 199 gray level scale is partitioned by the green lines, and the 144 and the other images pixel values are divided by orange line, and vice versa for the blue line and red line as depicted in the second image. So this is how we are explaining the three images, and this is the purpose of Haugh transform, that as input image we are extracting the edges, we are detecting the. Now edge detection and boundary linking during Haugh transform can be output of edge detection, valid edge points, previous techniques for edge linking, which is local processing. We should know position of straight lines. Region processing, we should have knowledge about region of interest to find out boundaries. Limitation, what are the limitations or what are the drawback of Haugh's previous or conventional edge detection. We should have knowledge about patterns prior to apply edge linking algorithms, which is not possible in every situation. We may or may not have the idea about the pattern designed by the image. What kind of objects are there, what kind of certain creations are there, we don't know how it will give the output. So the solution for such kind of problem is Haugh transform says a way of finding edge points in an image that lie along a straight line or curve. xi, yi, xj, yj is depicted from by the green and blue points respectively. Now we have drawn a line which can be says at the is straight line equation, which can be depicted as the straight line equation y is equal to ax plus. So now Haugh transform says in the different steps, consider one valid edge detection point xi yi in xy plane, and the equation of line passing through it can be yi is equal to axi plus b. As it is a point, finite lines can be passing through it, given by equation above equation and different values of a and b. We can write this equation b is equal to minus xi a plus ya. Eventually we have extracted the value of constant b, which gives us line in AB plane and parameter plane passing through fixed pair because it is having parameter xi, yi and xj, ya, j. It is a planar line. Now before we had a red line passing through green and blue points only. Now we are we are having b is equal to minus xia plus yji plus b is equal to minus xja plus yij. Now two lines are depicted on the same plane, that is a and b now are the axes replacing x and y respectively, and the lines b is equal to xia plus ye and line b is equal to minus xja plus yj are transformed accordingly. Now Haugh transform says we will consider to the second valid edge point xj yj and find out equation in parameter plane. It will be described as the equation b is equal to minus xja plus yj. If these 2 points lie on a set line in xy plane, then the two lines in parameter plane will intersect at point a dash b dash, where a dash is slope and b dash is intercept of line passing through 2 points xi, yi and xj, yj in xy plane. Now we can have the intersection point comparatively from the previous xy plane, now which is transformed to the AB axis, which is replaced from xy respectively. Now this intersection point is depicted by red point, which is having point A and B. You can solve these two equations, b is equal to minus xi a plus yi or b is equal to minus xj a plus yj in order to find out the intersection point AB. So the AB is having intersection point of these two lines, that is represented by blue and green. Now Haugh transform says there are certain limits and certain drawbacks and certain loopholes of this algorithm also. The drawbacks are slope A will be infinite in case of vertical lines, because suppose we are having parallel lines, so we may or may not have the intersection point, or in the mathematical format we can say the intersection point will be at infinite position. So in that case we cannot find out the intersection point. If two valid points are 3, 1 and 3, 2 respectively, it is taken as an example in this numerical line equation in AB plane, which is replaced from xy plane respectively. We are having 3, 1 is put the value 3, 1 in the first equation, that is b is equal to minus 3a plus 1, and they put the second coordinate 3, 2 in the second lines, b is equal to minus 3a plus 2. Here slope of two lines is equal, hence they are parallel in AB plane. So once we are drawing these two lines AB plane, it will draw in the parallel position. We cannot find out of intersection which gives us slope and intercept, that is a dash and b dash of line passing through 3, 1 and 3, 2 in xy solution. The solutions are, we can find out the radial format of the image. X cos theta plus y sin theta is equal to rho. It is perpendicular from the origin, and the angle from the x-axis, it is making theta angle. Once we have drawn a perpendicular on this line, so it is having equation x cos theta plus y sin theta is equal to rho. For horizontal line, theta is equal to 0 because it is not parallel, it is concurrent to the red line, and for the perpendicular line it is having 90 degree. Rho is equal to positive, tend towards positive if x intercept. For vertical lines, theta is equal to 90 degree and rho tend towards positive for y. Now minus theta and plus theta, minus rho and plus rho can be shown in the above direction. These are the pixel values, these are the pixels rays, and eventually they have find out the edge detection. They have partition in through the yellow point. They have find out the certain corners as well from the input image. So the yellow line depicts the partition or Haugh partition from the different level of grayscale to the very different level of grayscale. So this is the simulation work of the partition. Simulation work says either you can draw on the MATLAB software, or you can find out the output using Python, which is very useful language nowadays. So we can find out resolution of the image is 101 cross 101. So you can convert into the decimal format. Usually computer works on binary format, therefore they have defined the resolution of the image in 101 format or binary format. So D is equal to 144, and it is the illustration of Haugh transform. This picture is taken from Mr. Dr. Kate, Texas Instrument inclusively, and 234 intersection point, which is rho dash and theta dash, is represented by D divided by 2 comma 45. The intersection of the curves corresponding to points 135 can be defined there. So maximum distance between two opposite corner of image can be represented by positive D to minus 3.5 line detection by Haugh transform can be shown as, suppose we are having two rectangles, one is square and second is rectangle depicting upward size or the horizontal format, that we can transform into the different Haugh detection. So first and foremost, they have converted into the reciprocal format and converted into the Haugh binary image of the value 0 and 1. In the parameter for analytical curves are line, circle, parabola, ellipse. These are the parameters, and the equations can be written as, line can be represented as x cos theta plus y sin theta is equal to rho. Circle, which is having center at x0 y0, in this, if the case is center, then x0 y0 will have the value 0 and 0 respectively. So the equation will be make x minus x0 whole square plus y minus y0 whole square is equal to r square, where r is the radius of the circle from the point x0 y0. If the case of center, the center lies on the origin, then it is having the center equation x square plus y square is equal to r square. In this case, if the parabola is conditioned, then rho theta is also included. Y minus y0 whole square is equal to 4 rho excuse me 4 rho bracket में x minus x0. Then if we are having ellipse, then a b coordinates also included, constant terms are also included, which are the horizontal and vertical radius respectively. So x minus x0 whole square upon a square plus y minus y0 whole square upon b square is equal to 1. So so these are the real examples of the Haugh transform: infrared image, threshold, gradient image, Haugh transform, linked pixels. So certain theta values are there, cos thetas are there, certain edge detections and lines we can thank you.